Come on, everyone. Let's start off. So this was the last thing that we did. So we had a tunnel and the particles projected. Do note today there'll be no break. We'll be having class till 7:30 at a stretch. So let's go ahead. Hope everyone has gone through the notes. Others do keep your cams on. So last thing we did was this. We are playing with the tunnels ka thing. So let's continue with more tunnels. This would be a good one. It's a series of similar models, but there is a little variation in each one. So we have a solid sphere. And let's say this time you made a tunnel to the side. Center. This distance is d. So this tunnel at a distance of d, basically this tunnel is along the chord. And we have a particle m released from rest. And from the center, this is x. So x is the distance from the center of the tunnel. So till now we are taking the tunnels to the center, but this is not through the center. The mass m is released into the tunnel. So as this is falling, the first question, so if this point is A and this is point B, so find the time taken to go from A to B. Second one, so now when this thing is going through the tunnel, right? Now listen to this thing. When it is falling through the tunnel, the attraction force is towards the center like this, isn't it? That means this thing is just not going to fall freely. This thing will be pushed against the walls of the tunnel. Getting it? So there is some normal reaction between the tunnel ka walls and the particles. So plot the normal reaction versus x graph. And this is the force between particle and the tunnel ka walls. Others do keep your cams on. How do we do this? It's an SHM. Let's see. See. So when you make a tunnel here, so let's say the particle is here somewhere, mass m. So the force we will know is towards the center. So this distance is x, this distance is d, and let this distance be smaller. And this force is F. We know the force is mass into field. What is the field inside the solid sphere? G m small r by r cube, where smaller is the distance from the center. Is that clear, everyone? And this angle, let this be theta. So if I just draw the triangle again, so this was x, this was d, this was r. The force was acting like this, and this was the component. So if you draw the FBD of this particle, you will realize, see the forces on this. If this was the tunnel, the forces on this particle will be the normal reaction, this gravitational force, which is F sine theta, and the vertical force F cos theta. Clear with this? These are the forces. Then the normal reaction will be equal to F sine theta. F is nothing but G m small m r by r cube into sine theta. But what is sine theta from here? Sine theta from here is d by r. So you end up with G m d by r cube. You will find something interesting. N is constant. So when this thing is dragging on the tunnel, it doesn't matter how much it goes, the normal reaction is constant. So they can actually even something more. If they say the tunnel is having a coefficient of friction mu, find the speed when it comes from the other side of the tunnel. So you can even include work done by friction. So the normal reaction is constant. So if you try to plot the graph for this guy, n versus x, you will get a constant line. Plus x2 minus x. And if you look at the vertical forces here, we have F cos theta is equal to mass into acceleration. So we are taking acceleration in the direction of x. And F cos theta will be Gm by r cube into small r cos theta is equal to mass into acceleration. Small m cancels off and r cos theta will be, so we get A is equal to minus Gm by r cube into x. And this is your standard SHM equation. And this is omega square here. Therefore, the time period will be 2 pi root over r cube by Gm. Did you notice something? This answer is independent of D. Means it doesn't matter where you dig the tunnel, the time period for oscillation is same. You dig the tunnel in the center, you dig the tunnel on the side, any chord, it doesn't matter. And you can think of the logical reason also. When the tunnel is in the center, the force of attraction is also high, the distance is also high. If you make it a chord, the force is also less and the distance is also less. But remember, this is not the answer. This is the time period for one full oscillation. You're asking the time period only to go from A to B, so that will be only half of the time period, T by 2. It's only a one-way journey, isn't it? What you found was time taken to go down and come up. Yeah, so it doesn't matter, like, from on a planet you dig a tunnel from anywhere to anywhere, the time is same. Meaning you dig a small tunnel like this or dig a tunnel through the diameter, the answer comes same. And the best part is the normal reaction is constant. N doesn't change. It only depends on the distance from the tunnel. Clear with this? This is an SHM there. Any doubts on this? All clear with this? Soham, Parth? So just focus on understanding and solving the questions. Don't worry about writing. You'll get the PDF anyways. Next one. Same thing. What if I do like this? I have taken the planet. This time you have made tunnels like this. An equilateral triangle. The particle is released from rest here. Tunnel is smooth. Now find the time taken for one complete trip. So these edges are smooth, okay? So there will be, even if the collide E is equal to 1, so it will just keep moving. So this is A, this is B, and this is C. So find time taken to go from A to B to C to A. Right, Purvaja. Right, Pala. It looks scary. It's not tough. Think, I'll give you a minute. Right, Vihan. You got an answer? You can type in the chat box here to the co-host. Hmm. Three times. नहीं आ रही. Simple? नहीं? Can you see the resemblance? Just forget about the two tunnels. Doesn't this look like the previous problem? Just now we proved if you dig a tunnel, I don't care how you dig this, the time taken to go from A to B is same, right? So now if you just make one more tunnel, isn't it simply double of that? If you make one more tunnel, isn't simply three times of that? So whatever answer you got here, TAB, it is three times of that. Okay, so that's it. That was an easy one. From the previous part, we know time taken to go from A to B is T by 2, which is pi into root over R cube by GM. And you want to go from A to B, C, and A. This will be 3 times of TAB. Easy? So, but you need to know the result for the previous one. Then this looks easy. But exam they'll ask you this question only directly. All got this. Daksha, clear with this? Arya, Arnav, Dhriti, clear with this? Let's make something even better. What if we make tunnels like this? These are, the edges are smooth and the curvy, so the collisions will just pass on. So this is x is equal to 0. Let's say this is x is equal to r by 2. This is x is equal to minus r by 2. This is point A, this is B, this is C, and this is D. So you released a particle here from rest. So these edges are smooth. It's a smooth tunnel, and D is equal to 1. So this thing falls here. So this thing slides on this and then goes horizontally, slides on this, and then comes down. Find the time taken to go from A to D. This would be a better one. Distance of CB from center. I gave na R by 2 and plus R by 2.
Sir, x is equal to 0 is the center, right?
X is equal to 0 is the center. I know it doesn't look like center. The diagram is not up to scale. How do we do this? No, Puroja, that's not the answer. Maybe, huh? No, Daksha, that's not the answer. How do we do this? 3 5 by 2. No, Nikhil. I think I'll give you another minute. No, Falak. No, there, yeah. That's not the answer. नहीं अंश ज्यादा है क्या ना तुझे टाइम टी से ज्यादा नहीं आ रहा है आंसर help you see so think of like this. So when I'm making this, just forget about the rest of the tunnel. If I had just extended this, so when you go from here to here, this was the tunnel from A to B. If you had extended this, isn't this would have become a full chord? And we proved the time for this whole tunnel is T. You just want only A to B. So isn't this time T by 4? Isn't it? We have just calculated the total time taken to go from one end to another end is T by 2. But if you're just going from one end to the center of the tunnel, isn't it T by 4? Making sense? This is T by 4 and this is T by 4. If you had made a full tunnel. So, but we are interested only to go from A to B. So your particle is going to come from here to here. Now it is going to take a turn. Is that clear? That's the first part. Then the middle part of the tunnel, suppose if you had made a full tunnel, this would be x is equal to r, and this will be x is equal to minus r. So that is your extreme positions. This is x is equal to 0, and this is equal to x is equal to r by 2, and this is x is equal to minus r by 2. So you are asking, find the time taken for a particle to go from r by 2 to minus r by 2. So it's not a full SHM. In an SHM, it is a part of it. Is that making sense? And what is the time taken to go from r by 2 to 0? This thing we did in SHM, if you remember. There's a simpler way to remember this. Listen to this thing. R by 2. So sine theta is half. So sine theta is half, meaning theta is 30 degrees. So for full angle 360 degrees, you will take time period t. For 30 degrees, how much time will you take? T by 12. Unitary method. You're getting it? That's an easy way to remember this. For example, let's say instead of r by 2, it is r by root 2. Sine theta is r by root 2. So sine theta is 1 by root 2. So theta is 45. For 360 degrees, you will take time t, then 45 will take t by 8. You're getting how to remember that? So because in an SHM, we remember, right, a particle goes in a circle, the foot of the perpendicular or the shadow is going in SHM. So if you make one full revolution, you'll get time t. So you're going from r by 2 to 0. So then the time period will be t by 12 and t by 12. So this t by 4 will be the time taken to go from A to B. And you can see by symmetry, this is also the time taken to go from C to D. So therefore, the total time will be t by 4 plus t by 12 plus t by 12 plus t by 4. That is t by 2 plus t by 6 to t by 3, which is 2/3 of 2 pi root over r cube by gm. Is that making sense, everyone? So this itself is a part of its own SHM. You're getting it. This vertical tunnel is its own SHM. This horizontal is its own SHM. So there are actually 3 partial SHMs. You cannot combine this into one SHM. Inside CB ball. No, why will it bounce? This is a curve, na? So if you hit here at 45 degrees, you'll go down.
So, but when it first enters BC, then would it be like going up, down, like?
Array, just made it smooth, na here. Na. You just slide and go off. Don't worry about that.
Oh, okay, sir.
You just made the tunnel like this. So when the ball comes here, it will glide on this. It's not a
So it's,
flat surface to hit.
it's more like one
Don't
continuous.
worry. हाँ
Because
कंटिन्यूस
same.
SHM. चल ना अभी अर्थ में इतना बड़ा टनल बनाया. You didn't have a problem. वो एज पे थोड़ा कॉर्नर में you're having an issue. You people ना रे. When I made a full hole in the earth, you didn't have a problem with that. चलेगा बना दो बड़ा बड़ा holes. But ये edge में if I make a small curve like this, we have an issue. Clear with this? Let's see some more. This is a better one. So what if I have a tunnel in the center? Mass m and radius r. So this time, instead of releasing from rest, so till now all the particles that we are releasing from rest. This time you're projecting with speed v inside. V is equal to root over gm by r. So particle of mass m is projected into the tunnel with a speed now. Now find the time taken to reach the other end. So all these questions, right, are based on gravitation and SHM ka combination. And similar models you can do in electro also. We couldn't do these questions in SHM. Let's get this. How do we do this? This is a good one. Think. See, always before jumping into a question, right, ask yourself, like, okay, what makes the difference between this and the previous questions? Biggest problem, right? The first 1 minute, right? Don't jump into solving the question, unless you figured it out. Have some patience, think what is the difference thing. Can someone tell me what is the different thing so far? This is the first question we did. This is the second we did. Third we did. Did you guys notice something? Nee, that is okay. Did you notice this? Released from rest. Released from rest. Released from rest. Now I didn't release from rest. So now you tell me. One thing is clear. If you're in the tunnel, it is an SHM. So in an SHM, can tell me where will the particle be at rest? Extreme position, isn't it? So in all the A, B, C part, the particles were starting from extreme positions. But this particle is not starting from extreme position. Getting it? So this is like an SHM somewhere here. It is starting from somewhere there, and you started solving the problem, but between these two parts. So this initial position is not the extreme position anymore. Clear? So that was the thing you need to figure it out. Not try. I'll give 2 minutes. Right, Puruja, you got it. You have one answer. Vihan, outside it won't be in SHM, but that I don't care, right? The particle doesn't care what is happening outside. Outside, actually, we can't even calculate. Let's see. So this thing is falling. Now, let's first of all prove it is still an SHM. Meaning you need to understand it really doesn't matter. Max doesn't care what was your initial velocity here, but let's still prove it just in case. So if this was particle M and let us this is distance x. So the force on this particle will be mass into field. The field is g m x by r cube. So F will be g m x by r cube is equal to minus ma. Yeah, it is still SHM and it is still the same time period and nothing changed actually. So we are sure. Great. Now look at this thing. So this thing, so the extreme position is somewhere else. Now forget about the whole sphere and everything. You don't know. If you just look at the particle perspective, particle will think like this. I'm starting from extreme position. Then at some position, x is equal to r, I entered the tunnel. This was x is equal to 0. This is x is equal to minus r. Then I left the tunnel. Now I don't care what is outside the tunnel. So this is what the particle thinks. So just when I entered x is equal to r, my speed was root over gm by r. Isn't this the question looks like? So let me reframe the question. A particle is oscillating in SHM, right? When the particle is at x is equal to r, it has a speed of root gm by r. Is this making sense? Now, do you know the relation between velocity and x? V is equal to omega into root over a square minus x square. Remember this thing? The relation between velocity and position in SHM. There, I know velocity, which is root gm by r. I know omega from here, that is omega square, root gm by r cube. And this is root over a square minus r square. Gm by r goes off, and this will be r square is equal to a square minus r square. So we get a is equal to r root 2. Is that making sense? That means if you forget about the sphere and everything, this guy would have looked as if, so the whole question has become like this. We have an SHM where this is x is equal to a, r root 2. This is x is equal to minus a. And somewhere here we have x is equal to a by root 2, which is r. This is x is equal to minus a by root 2, which is minus r. And this is the center. Now, I don't care about the planet and all. So the planet was supposed to be somewhere here. You're simply asking me, find the time taken to go from a by root 2 to 0. A by root 2 means sine theta is 45. 45 is t by 8. T by 8. Therefore, time taken to go from a to b is t by 4. Are you getting this? You have converted literally the whole problem into an SHM. Check this out. So if I give you different speeds, it doesn't matter. I can still do the same process as the same. Is this clear, everyone? Got this? So you can play around like this. So the thing is, once you bring that SHM thing, right, you just remove the planet and throw it away and just see like, okay, this is an SHM. You have started from somewhere. So if you want to show like that, SHM, see, this is what actually happened. If you had a planet of radius r by root 2, r root 2, from this planet, you released it from rest. So it becomes a standard question. So while traveling in this planet, I wanted to find the time taken from here to here. Isn't that how it looks now? You're getting it. The equations would look similar. You can't tell the difference. Clear? Next one. Any doubts on this? So these are like the few models there which you can play inside our tunnels. You can make tunnels inside and do all that. This is primarily related to mostly SHM thing, but yeah, Gravi is involved. Let's see something else. So let's say we have a planet, mass m and radius r. So around the planet, we have a rod, not a particle, a rod, mass m and length is r. This rod is going around the planet. So this rod is slightly above the ground level. Just give me a minute. I don't know what happened. I got locked out. Yeah, I'm back. You guys are able to see me? I am not able to see myself. No, no. Now you can see. Vihan has saved us. Yeah. This is weird. This never happened before. It got kicked us out. So there, you got the idea there. I should have drawn them a little far. I have to draw too many now. So this thing is going like this. So this rod is always radial and this whole thing is rotating with omega. The rod rotates just above the planet. Such that it is always radial. So this thing now, there is a concept called space elevator. NASA ka website, right? They have a concept here. Now, you know what is the biggest problem we have while launching a rocket? The space travel ka biggest problem we have is the so the biggest problem we have in space travel is the cost of the fuel. Okay, so the thing is, let's say when you're launching a rocket or something, let's say rocket is fully loaded, and last moment mein you decided, you know, that you will feel hungry there, and you started eating a lot 1 week before, and you gained 20 kgs weight. होता है ना कभी कभी, or on a angry or something, you started eating a lot of pizzas and stuff. Now you will think, अरे 20 kgs only ना, क्या होगा? Now you're forgetting. So for that 20 kgs of weight, so to carry this extra 20 kgs till here, you need some fuel, let's say 200 kgs. But to carry this 200 kgs fuel from here to here, you'll need some more fuel. So think of like this: the fuel which you're going to burn 100 kilometers from the ground has to be carried, right? So just to, because of the 20 kgs extra weight, you might have to pack another 300 kgs of fuel. This actually becomes very difficult, actually getting it. If you put on that is the reason the weight ka thing is a very big deal. You have to put more and more fuel to just to take that more mass. So, you know, if Earth had been as big as Jupiter, right, if we would have died, we wouldn't have gone out of the Jupiter. It's very difficult to launch satellites and everything. So that is there. So then now the problem is what? The fuel that we use, right, is pretty expensive. One of the fuel they use is hydrogen, NH2, right? So it costs you a lot. And or also if you use liquid hydrogen and liquid oxygen, cryogenic fuel, these are also very expensive. So the biggest problem we have, right, in rocket thing is the fuel ka cost. End of the day, it is always economics. Getting it? So NASA has an idea. So what these people said, why don't we build a big elevator kind of thing, a rope going into the space? But who will hold it at the top? Someone has to hold it, right? So there's no one to hold there on the top. So, but if you're rotating, you have centrifugal force, m omega squared. So the centrifugal force is pulling it out, and the gravity is pulling it down. So if you can have a rope in such a way, the centrifugal force balances the weight. Then the rope will just stay there on its own, isn't it? And then you can send all the rocket ka parts and everything from the bottom to the top, like an elevator, and you can assemble them here and then launch rockets from here. So if you are really planning to establish colonies on Moon or Mars or something and do anything like that, you need to first make the cost of launching cheaper. But we have, so theoretically this concept is true. It works, right? It can be done, but practically we have a lot of problems. One of the problems that we face is, first of all, this length will be around 36,000 kilometers. The satellites which we launch, right, they're at a height of 400 kilometers. Getting at 36,000 kilometers, one. So that is one. So literally you're into the space. Second thing, agar is itna bada bana hai, right? Real estate people will first come start selling apartments. 50,000th floor. Normally you have what? Beach view, hill view. Ye to actually completely sun view, moon view, space view. You'll get pretty good names actually. So there, now the second problem that we face, right? One is the length and everything construction. Second is the material. This thing has so many stresses. The tensions at the bottom point, right? They reach almost 100 gigapascals. Giga is 10 power 9. Huge tensions. So the strongest materials we have on Earth that right now we use is the steel ka thing, alloy, which can withstand 5 gigapascals. That is a limit. But we do have a material which can withstand this kind of pressures, carbon nanotubes. Buckminster Fuller's, all that carbon nanostructures, right? They can withstand 120 gigapascals. So we do have materials which can withstand this kind of pressure, but unfortunately, the longest we made is 15 centimeters. We just need to make remaining 35,599 kilometers and 985 centimeters together. So something of that sort. We need to make such long polymers and all. The story goes like that. So this is a theoretically possible concept. Practically, we have issues. If at all we try to build something like this, I'm pretty sure it will take at least 500 years. And that too before if we don't go extinct by ourselves. Because people are more interested in how Salman Khan is dancing than really making something like this. Anyway, so this is how a picture would have looked like, something AI generated one. There you can see this thing like rope is going from there and this is there. So here the centrifugal force. Balances your gravity. So that is the thing. So there is no one actually holding you up. So the question is, this will not happen for anything. So find angular velocity of the rod. Find omega of the rod. Get this. We can add one more point. Suppose if you take x is the distance from the center, find omega of the rod and the tension in the rod as function of x. X is the distance from center. Remember, planet ka mass is m and capital R. The rod ka radius is also r. Let's hit both of them. You need to find omega and then the tension. It will be a pretty good paragraph question, or at least a more than one choice one. Let's try this. Others, do keep your cams on. Root G. How did you get X, Ray? X is a variable, na? Means you're saying every part of the rod will have different omegas. Nee, Rehan. Nikhil, did you get R plus 1 there? Is there R plus 1 in the denominator? Dimensions match nahi hua na re? In case you got an answer, you can type in the chat box to the co-host. R plus L. L is R only, na? The length of the rod is also R. There are two logins of mine. One is a host and co-host. You have to type to the co-host. I can't see you on the host. Root GM by 2R cube. No, let's see. So if you take this rod here, now at a distance x here, if you take a small piece, right now on this small piece, if you look at the forces, what are the forces acting on this? We have a centrifugal force, which is dm omega square x, and we have the gravitational force, which is gm by r cube into x into dx. That is a field into gmm by this thing. So x nahi aayega. So it's outside, na? Gm m1 m2 by x square. And what is dm? Dm is mass of the rod by length of the rod into dx. Now, let me tell you something. So can I write like this? Gm dm by x square is equal to dm omega square x. What do you guys think about this statement? If I write this, what does it mean? Is this even right? This is wrong. You know what? When you wrote this, you know what did you say? You are saying every point ka gravitational force is balanced by every point ka its own centrifugal force. Are you getting the meaning of that statement? This is the gravitational force on dx. If you equate these two, we have a problem. Gravitational force on dx, you're saying, is equal to centrifugal force on dx. And why that is a problem? Think about it simply. On the rod, which point gets attracted strongly by gravity? The lower point, isn't it? The one closer to the planet has highest gravity. As you go up, the gravity will decrease, 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 and decrease. Now, centrifugal force, which will be the highest? The farther the point, higher the centrifugal force. So the outermost point will have more centrifugal force and then decrease, decrease, and decrease, and decrease. You're getting what is happening? So every point ka centrifugal force need not be equal to every point ka gravitational force, but the total centrifugal force is equal to total gravitational force. Making sense? The moment I put an integral, suddenly they become equal. So gm dm x square is equal to integral dm omega square x. So putting an integral will change the whole equation. That is the meaning of with integral and without integral. Because the moment you put an integral, this becomes the total gravitational force. And this will be the total centrifugal force. And then you can substitute that. So this will be gm, and that will be m by r integral. This will be dx by x square. This is what I keep telling you. The integral is actually easy. The headache is getting the equations. This will be omega square x dx. And what are the limits? Remember, the center of the rod is x is equal to 0. The bottom of the rod is x is equal to r. And the last part of the rod is x is equal to 2r. So limits will go from r to 2r. M by r cancels off. This will be gm. That will be minus 1 by x. Minus 1 by x ka integral is 1 by... We could do that, Vihan. We can do that. Ask yourself. When you said that, what did you say? You were using center of mass. Vihan is giving us a suggestion. Sir, why can't I just replace this whole rod with just put one damn point in the center? When can you do that? Are the field constant? It's a non-uniform GMM by 1 by R square function. It's not even linear. If that was the case, if you guys remember the last problem we did, tunnel wala. So when you kept a rope inside the tunnel, why didn't we just the center of mass? You guys remember? We did something called center of gravity, COG. If the gravity is not uniform, you can't use center of mass concept. It doesn't work. We have to use center of gravity. To get center of gravity, you have to integrate. So better we do that only directly. This will be 1 by 2R. This will be omega square, and that will be 3R square. So we get omega is equal to root over gm by 3R cubed. Check this, everyone. Clear with this? Question still not over. You have to find the tension. What about that? That actually makes this question tougher. So if I have to put this in advance, right, I will ask you the tension. I can ask you even something better. Find the point with maximum tension. So in that entire rod, there's a one particular point with a maximum tension. I can even ask you plot tension versus X graph, meaning you can make this really deadly. If you start asking about tension in the rod, let's do that. Let's find the tension in the rod, and let's find the maximum tension in the rod, and let's try to plot the tension in the rod. Let's do everything. Now it becomes an advanced paragraph. If you just ask omega, it will be advanced ka, I can make it an integer or a single choice. Think of like this. It's like plain rice. You can put vegetables and make it vegetable pulao, so it becomes more complex. Let's find the tension in the rod. I'll give you a minute. Give it a try. How do you find tension? I keep telling you this. If you want to find tension, what you do? Let me give you something. See, you guys need to learn this, huh? When you see questions like this, suddenly something, find tension, everything, you need to always go back to your memory and think like, okay, did we do something like this somewhere? Look at this question, which we did in circular motion. We had a rod here rotating with omega, kind of gives you that kind of vibes, right? And we asked the question, find the tension at a distance x. And what did we do? See, at a distance h, we could take a small slice here, dx. And then we said the right side the tension is T plus gt, left side the tension is T, and this is the centrifugal force. And then from there, we integrated the whole stuff and we got it. So you can see some kind of resemblance there. So this is what I was saying, the first time when you see it might look tough, but you will observe these things keep popping up multiple places in different forms. You need to realize, okay, this is looking like that. Not exactly the same thing, but yeah, it gives you a similar thing. So this is what we do. Same thing at a distance x. We will take the small slice dx. Now, if I draw the FBD of that small slice, look at the forces. So we have tension T plus dt. So this tension is due to this part of the rod. You're getting it? You're being pulled on both the sides. And this tension is T. This is due to the lower part of the rod. And this is your centrifugal force, dm omega square x. And this is your gravitational force, gm dm by x square. There are total 4 forces acting on this small piece. Are you getting this? So when you take that small piece, there are 2 connections, right? The right side, upside, and downside. So both the tensions are pulling. So the tension increased slightly because of the small dx. So from here we will get dt will be gm dm by x square minus dm omega square. So this is the change in tension in the rod for a distance of dx. So dt is change in tension for dx length. This is one. Second thing, what will be the tension on the open ends? 0. You guys remember this? So at open end, the tension will be always 0 because there is no one to touch here, right? Suppose if there's a tension here, whom are you pulling exactly? In order to generate tension, you need to pull something, right? There's nothing here to pull. So the open ends will always have 0 tension. So this rod, the tension is 0 here and tension is 0 here, interestingly. So that means the tension actually increases and then decreases. This is the tension in the rod you're talking about. So yeah, we got everything. So let's go ahead. So dt, this guy will be gm. That will be small m by r dx by x square. This will be m by r omega square x dx. Limits. Tension is 0. Where is tension 0? You can take either x is equal to r or x is equal to 2r. Both will work. I will take x is equal to r. Tension T you want to find where? You want to find at x. These are the limits. Then we will get tension T is equal to, that will be gm small m by r, and that will be minus 1 by x ka integral. Substitute there. This will be 1 by r minus 1 by x. Minus m omega square by 2r, and this will be x square minus r square. This is your tension as function of x, everyone. Meaning you can simplify it further. Omega ka value you know na, gm by 3r cube. Take that guy and substitute here. I think still you'll get something complex, but you will get something. This is how you find the tension in the rod. Any doubts on this? It looks complex, but I think the moment you wrote this FPD, right, physics got over. How do you find the maximum tension? That's an interesting one. Actually, you need not do much. It's already done. Differentiate, right? So if I give you a function and ask you maximum, minimum, what do you do? dt by dx is 0. That means dt is 0. So dt I already have na. I already have dt. There's only to differentiate only. From differentiation only, I integrated this, isn't it? So for maximum tension, this can be a really good one if they ask you tension and everything. For maximum tension, dt by dx is equal to 0. So basically dt is 0 and dt is this guy. So you get a pretty neat answer. Remember, just now I made a statement, these two can't be equal. That means the other way around, the point where these two are equal is the maximum tension. there is a point where both the forces ka values will start, going away, like g dm by x square minus dm omega square x is equal to 0. So from here we will get gm by omega square is equal to x cube. And omega square is how much? Gm by 3r cube. So we get x is equal to 3 to the power of 1 by 3 into r. This is the point with the maximum tension. No, that won't be the center of gravity. This won't be center of gravity. So if you try to plot the graph, tension between x, the graph starts at x is equal to r, which is 0. The graph will stop at x is equal to 2r. So the maximum will occur somewhere here. X is equal to 3 to the power of 1 by 3r. So this guy will go up and then go down, something like this. This is how the tension will vary with x. Clear? No, COG का कुछ speciality नहीं है. See, COG is like what? It is a point where the net force seems to act. So if I ask you to draw some FBD or something for the whole rod, I can just write force here. But that doesn't give you tension at any point, isn't it? So you can simply replace all that force at center of this thing, and you can replace all the centrifugal force here, and then you can try to solve. So technically, as such, it really doesn't help you much. Is this clear, everyone? There, this is what you can do with this question. It's a pretty good one. So we have gravitation, we have circular motion, we have NLM, they're all combined. These are the kind of questions you should get used to it. If I just ask you for omega, that is still decent. But once I ask you for tension, the maximum value, graph, this is a pretty good one. Next one. So that's about a little about space elevator. Next thing, acceleration due to gravity. This is small g. So if you have a planet here, so when we keep saying, right, the gravity is small g, exactly what are you talking about? So we know the force of attraction on the surface will be g m small m by r square. So the person here, right, this is what he thinks. This itself is a gravity. So the force on the surface is nothing but mass into field. And this is what we write as m into small g. So technically, gravitational field is nothing but small g. That's a simple way to remember, isn't it? The force by mass is nothing but gravitational field. So the gravitational field at any point is nothing but the g at that point. So E is nothing but gm by r square. This is on the surface. So g on the surface will be gm by r square. So this is what we keep writing as gravity. And if you put the mass value as density, so g into rho 4 by 3 pi r cube by r square, this turns out to be 4 pi by 3 rho g r. So if they give you the mass of the planet and radius of the planet, you can use gm by r square. If I give you density of the planet, I can use that one. This is the result you should remember. So gm by r square is g. So if you try to put the values of the mass of the Earth and radius of the Earth. So G of the Earth comes to be 9.81 meter per second square. Again, remember, this is only on the surface. If I try to put the value of Jupiter, this comes to around 62.1 meter per second square, roughly 62 meter per second square. So Jupiter's gravity is 6 times more. So if you actually go and land on Jupiter, there is a high chance you won't come out. So whatever satellite that you send to Jupiter, it is gone. There's only a one-way journey. You go, but you don't come back. You don't have enough fuel to escape the Jupiter gravity. But on the other hand, if you look something like Moon, this guy is cool. It is only 1/6 of the gravity. But we have other problems. Because the gravity is so less, even the atmosphere escapes. Getting it? The gravity is so small, even the atmosphere escapes. That's why Moon doesn't have an atmosphere. So you can't go and live on Moon. So Earth is in a very perfect spot. We don't have too much gravity. We don't have too less gravity. We have exactly sufficient, so that we can sustain. And when you think about that, right, it's like I read this somewhere, there are 42 different variables that have adjusted precisely for their life to exist on Earth. 42 variables. What are the distance from the sun, the temperature, the size of the Earth, the radius of the Earth, the density of the Earth, the atmosphere, every damn thing. Like 42 variables. And even in that one variable had been wrong, the Earth would have been like a desert or a frozen planet and there would be no life. And when you think about that, now imagine 42 things being exactly same. Meaning probability says, boss, it doesn't work. So maybe we are just an experiment, isn't it? Just like we grow some ants in a lab, someone is actually growing us in a very nice controlled environment. We will never know. Clear with this? Or maybe who knows, this might be completely in computer simulation. If I say this kind of thing, then you'll say, then theek hai, then JEE ka padne ka zarurat nahi hai. This is a simulation, so anything can happen. So these are the kind of things you think one day before the exam when you don't want to study, right? And then you do all this kind of nonsense. Great. So this thing what we got is on the surface level. But what if you start going above the Earth's surface? Variation with height. So if you go to a certain height here, m, at a height h, like I just said, the field is nothing but force. So m into g apparent. So you'll feel the weight is a little less. We'll call it mg apparent, which is m into field. So g apparent is nothing but gm by r plus h whole square. Standard formulas. Now if you take out that r common, you will get gm by r square 1 plus h by r whole square. Therefore, we get g apparent will be g on the surface by 1 plus h by r whole square. Definitely remember this. If h is much less than r, when I say much less than r, example, radius of the Earth is 6,400 kilometers. Let's say h is 100 kilometers. Anything less than 5%, we can call it small. Then we can use binomial approximation. Then g apparent becomes, I hope you remember what is binomial approximation. 1 plus x whole power n is 1 plus nx. So this guy becomes 1 minus 2h by r. So in case you don't know, 1 plus x whole power n is approximately 1 plus nx. So here you can write this thing as 1 plus h by r whole power minus 2. This is approximately 1 minus 2h by r. So that's a binomial approximation. But you can use it only for small h. Be careful with that. There. That's your result when you go up the surface. Same thing if you go variation with depth. What if you go into the Earth? If you go into the Earth, this is d. Same story here. So this distance will be r minus d. So g apparent will be the field, which is gm by r cube into r minus d. So this guy will be g into 1 minus d by r. There's an approximation. This is the perfect formula. So this works properly for depth. You can note it down in case you want. Yeah. Now, what happens? There is another way to change the gravity. What if you rotate? We did this in circular motion. So if you have a planet rotating with omega, and if you stand somewhere here, so this is theta 0. So here theta is called co-latitude angle. So theta 0 is your equator. So now what happens? This person will be going in a smaller circle here. So if this angle is theta and this radius will be r cos theta. Now if you look at the forces on this person, he will experience a centrifugal force m omega square small r, and the gravity will experience this way. So the forces will be at an angles. So if you look at this person FBD, you will realize this. This will be your mg. This component will be m omega square small r cos theta. So this person will see G apparent will be G minus omega square small r cos theta, but small r is capital R cos theta. So this turns out to be G minus omega square r cos square theta. So be careful, it's a cos square theta. You get one cos theta because of radius and one cos theta because of force ka component. So when you're on a planet, the gravity varies because of rotation. On the North Pole and the South Pole, you get exactly right, but on the equator, you get the least gravity. So that is the reason whenever these people are launching rockets, we prefer to have a launching station close to the equator. Saves you fuel. So at equator, if G apparent becomes 0, suppose if the Earth starts rotating pretty fast, then omega becomes root over G by R. So there was a PYQ like this. If the people on the equator start feeling weightlessness, what is the time period of revolution of the Earth? So matlab G apparent has become 0, and then omega is root G by R, and from there you can get the time period. So these are the three ways you can mess up the G apparent: with height, with the depth, and with rotation. Is that clear, everyone? So let's see a question. See how we'll ask questions on this. So we have a planet. Find the distance from the surface where G apparent becomes G by 4. If time period of a simple pendulum on surface is T, at what height will it become 3T? A barometer shows 75 centimeters on surface of the earth when pressure is P naught. At height 3r, barometer shows 90 centimeters. Find the pressure at that point. So literally wherever there is G in all the questions, you can use this thing, right? 3r. The G apparent on the surface of equator is equal to G apparent at a height h above North Pole. If h is much less than r, find h. There. 4 questions, like all are simple mains level ones. The first one has 2 answers. Be careful. I never said height. I simply said at what distance from the surface. So there are 2 things, one above the ground and one below the ground. So you have to get both the answers. Get them all. I'll give you 3 minutes for everything. Then we will discuss one at a time. You try whatever you think you can get. Should I show the first one? Others, do keep your cams on. Look at the first one. So you said G apparent is G by 4. So if you are looking at height h, this will be G into, be careful, don't use the approximate formula because the change is too big. Square. So 1 plus h by r is equal to 4. H is equal to 3r. So at a height of 3r from the surface. If I'm using the depth ka thing, G by 4 is G into 1 minus d by r. Then Gg will cancel, then d will be 3r by 4. That's the depth from the bottom. Easy. You just need to put the formulas and you'll get the answers. Now try the rest. Two? I don't know. 2r you mean to say? Could be. The first question, is it 2? You're right. Square root है ना? I did a mistake. You're right. What is the second question? If the time period of a pendulum is t, so time period on the surface plus 2 pi root over L by G on the surface. And when you go to a certain height, you're saying the time period has become 3t. So this has become 3t, which is 2 pi root over L by G apparent. So just substitute here. So this is 3 into 2 pi into root over L by G is 2 pi into root over L by G apparent. So G apparent will be 2 pi, 2 will cancel, L will cancel. You end up with G by 9. This is nothing but G into 1 plus H by R whole square. So 1 plus H by R square is 3 and H by R is equal to 2 and H is equal to 2R. Easy? Yeah, it is all about that. Get the G apparent, put in the formula and you're done. What about third and fourth? Look at the third one. Do you guys remember the barometer ka formula? Height of the barometer is given by pressure by rho G. P is equal to rho G H, isn't it? This was the formula, the height of a barometer. So when you put a barometer there. So now you're saying initially this height was how much? 75 centimeters when pressure was P naught. So at height 3R, your H apparent will become, G apparent becomes G by 1 plus H by R whole square. That is 1 plus 3, that is G by 16. Agreed? So now the new height will be, the outside pressure also will change. So P dash, density will remain same for the mercury and this guy became G by 16. So from here, and you're saying the new height is 90 centimeters. And this guy was 75 centimeters. So yeah, I need to get rho G from here. So rho G will be P by 75, substitute here. So this is P dash, rho G is P by 75 into 1 by 16 into 90 centimeters. 15 5s are 15 6s are. So pressure at that point will be 3P by, that is 2 3s and 8s are 40. Yep, this will be the pressure at that height, 3P naught by 40. Is this clear, everyone? Clear, Parth? Parth, you're getting everything right? Are you sure? Yeah, please ask me if you have a doubt something. What about the D part? G surface on the equator, the D1 is kind of a PYQ actually. So see the question, on the surface of the equator, the gravity, and when you go on a north pole little height, the gravity is saying it is equal. And what is that height H? Let's see the D part. So what is the G apparent on the equator? The G apparent on the equator is G minus omega square r, theta is 0. Now G on the height will be how much? You're saying this will be G into 1 minus 2h by r because the height is small. That's it. This much only you're done. So G and G will cancel. You end up with omega square r is equal to 2h by r. So h is equal to omega square r square by 2. Easy. You just need to apply the approximate formula because h is much, much smaller. Next one. This is a good one. So we have a planet. This guy is rotating with omega root over g by 4r, mass m and radius r. So A is a point on a surface. Then what happened? Due to internal forces, the planet shrunk. Do you guys remember where we did something like that? The planet became a rotational mechanics. So this planet became mass is same, but the radius became r by 2. So something happened. The point A is still on the surface. So the question is, find the ratio of G apparent on the surface before and after. Let's get this. How do we do this? This is a good one. Take 2 minutes, figure it out. A lot of things are happening here. How do we approach this? Hmm, 3 is to 8. 3g by 4 and g by 2. Most of you got it. Let's see what happened here. First thing. This is your omega, which is root over Did I give you some value? G by 4r. Yeah. When the planet has become radius r, I hope you remember conservation of angular momentum. I1 omega 1 is equal to I2 omega 2. This will become 4 omega, which is 4 into root over G by 4r. So that is 2 into root over G by r. So there are no internal forces. So torque external is 0. L1 is equal to L2. So we have I1 omega 1 is equal to I2 omega 2. 2 by 5 mr square omega is 2 by 5 mr by 2 whole square omega dash. So we get omega dash is 4 omega. This is the first thing that happened. Omega got messed up. Second thing that happened, this is where people generally mess it up. Now, when you say G on the surface, ask yourself, what are you calculating exactly? So this is G mm by r square, and this was a centrifugal force, m omega square r. So literally, this is what you're calculating. So m into G apparent will be G m by r square. That becomes small g. So basically, G is G m by r square minus m omega square r, and omega is G by 4r, and this guy will be 3G by 4. So this was the initial G apparent. Now see what happened. This point A, it came closer. This is the first mistake. A is still not on the same position. Now your gravity becomes G m small m by, this radius is r by 2 whole square. So the person on the surface will think the gravity became 4 times. You're getting it? Just getting the planet closer, the gravity increases. The centrifugal force also messed up. So m omega dash square r dash. So everything changed. So now the mg apparent will be, this guy will be 4 times g mm by r square. So the gravity changed. Omega changed. 4 omega ka whole square. Omega dash is that. 2 into root g by r. The radius also changed, r by 2. This guy will be 4g minus 2g. So g apparent will be 2g. There. So the ratio will be 3:8. So if you look at the second formula here, this thing mg changed, omega changed, radius also changed. All the 3 terms changed. Have a look at this. Clear? Next one. So then those are 3 main things you have to be careful. Next thing is satellites. So this we didn't have in electrostatics. So what's a satellite? An object that revolves around a planet. In a stable orbit. So when you stable orbit, meaning it's a bounded orbit. When I say bounded, it means 2 things. One, the orbit must be a closed orbit, like a circle or an ellipse or something of that sort. You can have other things also, but circular orbits and elliptical orbits are common. Mostly ellipses are more common. Second thing, these systems have total energy is negative. Means if you want to make the satellite go away from the planet, you have to provide energy. That's how you know a stable orbit is stable. It should be closed and the total energy must be negative. Right? So now if you take a planet of mass m, and let's say we have a satellite going around it at a distance r, the forces on this planet will be the traction g by r square. The centrifugal force is mv square by r. So you can equate them. So we have gmm by r square is equal to mv square by r. So we get v is equal to root gm by r. Quite a useful one. You should definitely remember this. So if you're going to put a satellite at a distance r from the center, this is the speed it will go. The closer the satellite, the faster it goes. The time period is given by distance by time. In this case, the distance is the circumference, which is 2 pi r by v. So if you substitute here, we get time period is equal to 2 pi root gm r power 3 by 2. And be careful, what is this m? This m is the mass of the planet, not the satellite. That means if I know the time period of a satellite and if you know the distance from the satellite, I can find the mass of the planet. Ever thought about it? Mass of the Earth is 6 into 10 power 24 kgs. Who measured it? You took the Earth and put it in a spring balance. Yeah. This is what we must have done. We know the time period of a satellite. We know the distance of the satellite. If you put it there, I'll get the mass of the planet. That is how you can find mass of the sun. So this is how you find mass of planets or stars or something indirectly. No one actually goes with a measuring balance and measures them. Have a look at this. So that's the main things there. Clear? Then if this satellite, if this radius r gets closer to the radius of the planet, generally most of our satellites that we launch, right, are pretty close to the Earth, matlab 200, 300, 400 kilometers. Even International Space Station is at a distance of 650 kilometers. It is very expensive, costs you a lot of fuel to go very far. So we generally don't put satellites in a very high orbit. So V orbital becomes gm by r. This can be written as root over small gr, because small g is gm by r square. Now, in this, we have something called a geostationary orbit. Now look at the word. The word is self-explanatory. Geostationary. Geo is Earth, stationary. So the person on the Earth will think the satellite is not moving. It looks like a fixed point in the sky. When will this happen? This will happen if the angular velocity of the Earth and the satellite is same. If both rotate with the same omega, you will think it is the same thing. That means the time period must be equal to the time period of the Earth. 24 hours. Time period of Earth. So we have t is equal to 2 pi root over gm r power 3 by 2 is equal to 24 hours. And when you actually calculate this, this guy comes to close to 42,000 kilometers. This is from the center of the Earth. So from the surface, it is roughly around 36,000 kilometers. And it is so expensive. If you want to put something in a geostationary, the amount of fuel that you spend money on that, you can actually easily launch 10 to 12 satellites in the lower orbits of 300, 400 kilometers. That is much cheaper. So, but we have a problem. Let's say you launch one satellite and you want to use it. Now, most of your phone calls that you do, right? We don't use any satellites. They all go through the optical cables which they dug up under the ground. Getting it? This was something like 10 years back. 10 years back, Reliance itself had around 125,000 kilometers of optical cables. Now it must have at least tripled. So every time you make a phone call, the signals go to the tower. From the tower, it goes through the wire, the optical cable, and then reaches the other person. But imagine, right? Indian Army is fighting a war in the Himalayas and all. Now there you don't have cell phone towers. The only way you can talk is through satellites. Getting it? Let's say we have hills and everything. One battalion is here, one group is here, and they need to talk. And there's no way you can communicate. So satellite communication is the only way. So during Kargil war, right? Indians, we didn't have satellites of our own. We are using US ka GPS. And in the middle of the war, right? US was pissed off with both India and Pakistan, mostly with India. And they said, like, India, if you don't stop the war, we are going to put sanctions and blah, 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 blah. As usual, we didn't listen. And then they just kept sanctions and they just switched off the GPS in the middle of the war. Just imagine, like, lakhs of soldiers, right? Stuck in between the mountains and everything. They had no communication. Literally, everyone was blind. So no one knew where the battle formations are, where the tanks are. Everything was cut off. And that's when, people decided, boss, we can't depend for military purpose on other countries. So that is when, ISRO got a boost. And luckily for us, space technology, right? Rockets and everything, no one gives you the information. No country will share it with you. So you have to do it on your own. So ISRO got even better advantages. We have nothing to do and no one is going to teach us. So we have to figure it out on our own. And if you see, we figured it on our own and we are pretty strong. And vice versa, if you go to DRDO, that is also a defense research organization, right? It does mostly shitty work. A simple reason, because every country is ready to sell weapons. It is cheaper to buy weapons than do research, and you get good bribes also. So, yeah, it works out, and that is the main reason. So, even government organizations work well if they are incentivized properly, but that is what happens. So, the problem is what? So, if you launch only one satellite, this is what will happen. You keep the satellite here. Let's say you want to talk between Mumbai and Delhi. So, this is sending signals like this continuously. But this thing is going so fast because you're pretty close. This will go behind here. That means you can use the satellite only for some part of the day, isn't it? So if you have only one satellite, this is what happens. You can use this only, let's say, when the satellite is in this region, only this signals will go, isn't it? Satellite only covers this much area. Once the satellite crosses this line, you can't talk between them. You don't have access to the satellite. So it will be like this. Every 4 hours, you get access to the satellite for 1 hour. So what people do, instead of using one satellite, we use multiple satellites. We form a constellation kind of thing. So every time this satellite goes out of the orbit, new satellite comes into the orbit. So in a military GPS, we use 24 satellites. So we have 24 satellites orbiting. These things are very high precise. These are so precise. The cameras are so powerful. You can see car ka plate number. You can see car ka plate number. They're that precise. So anyways, it is good they're precise because when they launch missiles, they have an accuracy of 1 inch. Isn't it? Someone wants to launch a missile to your neighbor. You don't want the missile in your house. So precision bombing, we call it. And making bombs better saves lives. Looks weird, no? But it does. You know why World War II was so destructive? World War II was destructive because they didn't have good bombs. Seriously. Because this is what used to happen. There is a weapons factory here and you want to destroy this. And these planes are flying at a height of like 4 to 5 kilometers. You don't have proper targeting systems. Now you want to destroy the factory at any cost, but one bomb won't do the job. So what these people used to do, they used to bring 50 to 60 planes, 50 to 100 planes, each one loaded with 5 to 10 tons of bombs. And because I want to hit this place, you start bombing from here. This is called carpet bombing. Like a carpet you put on a floor, you put bombs continuously. So 1 kilometer before the factory, 1 kilometer after the factory, you just bomb everything. After doing that much, sometimes the factory is still there. Everything got destroyed, factory is still there. So to be sure, while coming back, you do one more bombing. So half the city goes off to destroy that one damn factory. And in this, people used to die unnecessarily. People had nothing to do with the factory, they died. So most of the cities were devastated that way. But now we have precision bombing. Ever heard about this thing? In Pakistan, there's a particular building, US launched a missile and destroyed it. And no one knows also. Within 100 meters, no one knows also the building was gone, meaning you can destroy buildings so precisely. So there. So what did you learn from this? Make better bombs, make people lives better. Nice slogan, no? So there, kind of works. It looks weird. But now look at the satellites. These things, right? You just can't launch however you want. There's a restriction. Every satellite that you launch, the center of the circle must be the center of the planet. Why is that? Center of the orbit must be the center of the planet. Think about it. What if it is not? What if you have an orbit like this? Now, if you draw the FBD of this, the gravitational force will be this way, G_mm by r square. The centrifugal force will be this way, m omega square r. Do you think the forces can be balanced? Forces can't be balanced. So this will be an unbalanced forces. You can never have a satellite like this. These kind of orbits don't exist. We have to put some kind of an external rockets to maintain this thing. It's useless. So you have to launch all rockets like this only. The center of the circle must be the center of the planet. Now, in this, geostationary is even more special. If you look at geostationary, this must be in the equatorial plane. Why is that? Think about this. Let's say you and the satellite have same omega. You are rotating this way and the satellite rotates this way. Do you think it is stationary? You have to rotate in the same plane as the Earth, isn't it? So that means geostationary, right? If you see, every country has only one geostationary orbit. If everyone decides to put a geostationary orbit, we all have to put it in the same orbit. So India ka satellite is here, US ka is here, Russia is here, Europe is here, everyone is there only. And one satellite gets messed up and that will, destroy all the satellites in the orbit. It's pretty risky actually to put even a geostationary thing. So there. Clear, everyone. So that is about little about orbits ka thing and geostationary. So if you have a planet and if you have a satellite, you need at least 3 satellites to cover the entire planet because the signals will always travel tangentially. You need at least minimum 3. But like I said, people generally use multiple ones, like 8 to 10. You need at least 3 satellites to cover the whole planet. They have to be kept at a precise distance. This will be like a PYQ in CAT or something. How many satellites are required to cover the communication for the entire planet? Minimum. So that will be 3. Did you guys ever think about this? How does a GPS know where you're standing? When you're using a GPS, how does your GPS or what is the process? Ha, Daksha, bolo na.
I had a doubt.
Which doubt? Bolo na. Regarding orbits?
Yes, sir.
Bolo na.
Sir, so usually like when stuff is difficult to achieve, then it's got advantages, right? So
Which one?
sir, so like if that random orbit, if we are able
Uh,
to station the satellite with that, like using whatever
this one.
and all that. Yes,
This
sir.
one you're saying.
Yes, sir.
Problem is you will be consuming your fuel continuously, right?
Sir, but is there like a significant advantage to that?
Nee. it will be too costly. Problem at the end of the whole story is about the fuel only. No one actually cares about the satellite. Making the satellite is cheaper. The fuel is becoming more expensive.
Okay. Okay.
That way. It is all about this thing. Meaning keeping in that orbit 24/7 will consume huge amounts of fuel. And there is no significant advantage if you're asking. It is better you launch 10 rockets and keep them in orbit. Like what Elon Musk is doing. He literally creating a constellation. Something of that sort. It's not one or two. He has thousands. He is thinking like something like this. He is saying, let's cover the whole planet with thousands and thousands, lakhs and millions of these things. It's like small flies just flying around the planet. You can actually stop global warming with that. If you can put enough of them, they can shield the sunlight. You can actually decrease the Earth's temperature. But you have other problems also. They will become actually projectiles, and if you launch these things, they go with very high velocities. They call it space debris. It's like you're polluting the space. So we have other effects also. So again, I was talking about this thing. How does your phone or the GPS know that where you're standing? Remember this thing we discussed in foundation. There's something called triangulation. Ever heard about it? So this is what happens here. Let's say we have a cell phone tower or something here. Now the cell phone tower, right? When you send a signal, let's say from your phone or some GPS device, you're sending a signal. Now the thing is, how does this tower know where you're standing with this just a signal? It doesn't know. So what happens, right? Whenever your phone is sending a signal to the tower, in that signal there is a message. So that signal in the beginning of the message, right, it will be written. The signal is sent at 10 o'clock, 31 minutes, 14 seconds, 23 milliseconds, something like this. More digits, milli, something of this sort. So a timestamp is sent to the cell phone tower. When the signal receives the tower, it also gets a timestamp 31, 14, 23, and let's say 35. It travels with speed of light. So time changes in very small decimals. You're getting this? So now look at this, what is happening. The tower knows when the signal was sent. The tower knows when the signal is received. Agreed? So I know the time difference. Multiply this with speed of light. Then I get the distance. Now the problem for the tower is, I know the distance, but I don't know which side. So tower will assume you are anywhere on this sphere, isn't it? Tower doesn't know. You can be anywhere on this sphere, the center of the tower being the center of the sphere. Then we need one more cell phone tower. This also will get the signal. This also will do the same thing, right? So this will also draw a circle. And these two towers are also talking to each other. Now, both the towers know that you have to be on a circle, on a sphere, and there are 2 points of intersection, isn't it? Now, you can be standing here or you can be standing here. So to confirm, we need a third satellite. And there'll be only generally 1 point of intersection. If you make 3 circles and the 3 towers are talking to each other continuously, that's what we call it a triangulation. You're making a triangle out of it. This is how systems know where you exist. Getting this thing? So this is a mathematical way of figuring out what is happening. When this is a very basic thing, it's more complex. You do a lot of stuff and everything. Clear? Next thing, the energy of a satellite. Now, if you have velocity, time, and everything, you also have energy. So this guy is going in an orbit of radius r, mass m. So we have potential energy is minus g mm by r. Kinetic energy is half mv square. V is equal to root gm by small r. So this guy becomes gmm by 2r. The total energy will be, just add them up. Potential plus kinetic. Kinetic is positive, potential is negative, gmm by 2r. And now if you take the ratio, total energy is to potential energy is to kinetic energy. This was a question they asked in the exam. The ratio will be -1 is to -2 is to +1. Quite an important result, a proper mains level question. In a satellite, find the ratio of total energy, potential energy, and kinetic energy. And now if I try to plot a graph, so this is another way they can ask a question. So we have 3 graphs like this. Can you tell me which line is which one? The green line, red line, and the black line. Can you tell me which one is kinetic, which one is potential, and which one is total? Which one? The green one is positive, so that is your kinetic energy. The red one, the black one, if you see it is more negative, so this is your potential energy. So potential energy is more negative than the red one. Red one is your total energy. Is that clear, everyone? Clear? And then one last one, the escape velocity. I will finish all the theory till here. Here are some pretty good problems on this. So what is the escape velocity? The minimum speed required to escape from the surface of the planet. To infinity. So if you have mass m and radius r, and you're projecting with u and an angle theta, so this guy will go to infinity. So initial energy will be minus gmm by r, the potential energy. The kinetic energy is half mu square. You are at infinity, so potential energy is 0. Kinetic energy is also 0 because you're going for minimum. So we will get V escape is equal to root over 2gm by r. This can be also written as root over 2gr. And if you observe something, this is independent of theta. Meaning from a planet ka surface, it doesn't matter how you throw, it'll escape to infinity if you throw with this velocity. And here we can do something interesting. If you take this V escape, which is root over 2gm by r, and if you say this is less than or greater than equal to c, where c is the speed of light. So that means for a planet or a star, if you make the escape velocity greater than speed of light, we end up with r is less than equal to 2gm by c square. This thing is called Schwarzschild radius, a German scientist ka name. So this is a condition for black hole. If a planet or a star or something reaches this radius, it becomes a black hole. You need to understand there's a c square sitting in the denominator, huge number that is. So you know how to make an earth into a black hole? Imagine this. Take the earth, compress it, and put it inside a tennis ball. Just look at the kind of compression you're talking about. You take the entire earth and put it inside a tennis ball, and you get a black hole. That is how massive and dense the black holes are. Can you just even imagine putting the entire earth in a tennis ball? Just तेरा room का size देख and look at the size of a tennis ball. Now we are talking about the whole earth. And generally these black holes have a radius of 10 to 15 kilometers, the chota ones. Now imagine a 15-kilometer black hole, matlab the star must have been how big. And we also found out in the center of our galaxy, there is one supergiant black hole. So that's a different game altogether. There, so that is a bit about it. So next class when we catch up, we'll continue from here. And we'll talk about more about this thing, the formation of a star, what happens with that and everything. We have a little discussion on that. That's a one pretty good discussion which combines thermodynamics, electrostatics, and gravitation. That could be a good advanced paragraph. So we'll have a discussion on that. Then we will see some good velocities and all. You guys remember there's a movie Akshay Kumar ka Mangalyaan, I guess. They send a rocket to Mars. I'll explain you that movie also. The question what they tried to do The movie was horrible, but it's a pretty good question. Right. So we'll talk about that. Mostly next class we will wrap up the chapter, because we are only left with satellites. That is the main thing there. We are going to do that. And once this is done, we'll start off with Gauss laws. Okay, so with that, we'll wrap up for the day. And like I already informed before, next week we are on a break, so we will directly catch up again on May 6th. Right, and there are 2 tests also